ahead, this topic that we're going to go over today is real-time data streaming with Snowflake and Confluent. The idea is that we wanted to show how we can leverage both of these systems to create a constant influx of data from any different source, but we've picked a topic of cryptocurrencies for today. So I work with a company called Big Compass. Our motto is data agility. We define that as the ability to quickly move data from source to value. And we help companies do this for deeper insights and just streamlined automations of your processes so that you can make sure that the data is where you need it, when you need it, and expressed in a way that makes sense to your business. We picked two technologies for today, as everybody knows, Confluent and Snowflake. We're proud partners of both technologies, and we take every opportunity we can to show off both of them because we believe that of the types of technologies they are, both Snowflake and Confluent kind of stand apart and provide a lot of unique features that you can leverage for some pretty powerful services. My name is Heartland Brown. I've been working here at Big Compass for going on 4 years. My specialty, just due to the nature of our work, is data warehousing and integration. Anything that has to do with connecting data from one point to another is generally something that I'm not only experienced in, but passionate about. I was born and raised here in Colorado and pretty much enjoy doing anything outdoors. If you ask anybody here at Big Compass, they're gonna say that I'm usually pretty obnoxious about the fact that I mountain bike, rock climb, snowboard, and scuba dive, as well as because I'm here in Colorado, I hike every large mountain that I can find. For our agenda today, we're just going to go over kind of an overview of Snowflake and Confluent, why we picked these tools, just what we're leveraging as far as features. And then we're going to go into real-time data manipulation with Snowflake and Confluent, just present kind of our architecture and our tools. And then for our demo, we're going to kind of walk through each of those steps in the architecture and show you how we set it up. And then, of course, at the end, we'll have a QA session. For that QA session, please just make sure you post your questions in the chat and Stephanie will bring them up. All right, so starting with Snowflake. This is easily one of our favorite pieces of technology, particularly when it comes to data warehousing. The first thing that we always mention anytime we're talking about Snowflake is there is literally no setup. There's no hardware. All you have to do is pretty much sign up for an account and you hop in and you're ready to go. You still have to do, for long-term security governance, there's obviously a little setup with roles and stuff like that, but for provisioning and just getting everything going, it's pretty much ready right out of the box. And I'll show you today just the SQL statements I used to set up everything that we are doing today, numbered less than 20. This cloud-based, the fact that Snowflake lives in the cloud, be it GCP, AWS, or Azure, gives it easy access to other cloud applications. Today, we're going to just show that with a really simple dashboard that I made in Tableau that sits on top of the view. And then, of course, the features that we'll be leveraging are some of the primary benefits of Snowflake. One of those is asynchronous event-driven consumption with Snowpipe. This allows you to dump something into your cloud storage, whether it's a GCP bucket or an AWS S3 bucket, and those will automatically get consumed into Snowflake. We'll go into that a little bit. And of course, it also allows consumption of semi-structured data, which is the big thing that kind of stands out. Today, we're going to be doing CSV as our semi-structured data. But in general, you can do far more complicated things. You can do JSON, you can do XML. For the simplicity of the demo, we just decided to stick with a CSV architecture or a CSV format. As far as Confluent goes, obviously this is real-time messaging. One of the big benefits that we took advantage of today is that you can actually deploy your own server on premise or in the cloud. Today, we chose to use an EC2 to deploy our server, and that'll be running most of our front end, the beginning of our architecture. It's highly customizable to fit all use cases. You can set up messaging windows. You can make sure that you have multiple nodes, and you can partition across those nodes. For today, we're just using a single node architecture, so there's not a whole lot of partitioning involved. But in general, you can make this as simple or complicated as you need to. It also maintains records for historical reference, which is something that overall we're gonna leverage today just to show you that we've been consuming data for a little bit. And one of the big features that we're showing off today is that Confluent can be managed and interacted with using KSQL, which is a SQL-like language that allows you to do real-time manipulation and transformation of data, including joining topics together as if they were tables. All right, so real-time data ingestion and manipulation. The demo premise is that we wanted to pick something highly volatile just so that we could show changes in this data over time. It's going to be easier to do this with cryptocurrency just because second by second, any coin on the market can change pretty drastically, whereas something like the stock market or even inventory or transactions are going to be a little more static and a little more slow flowing. Big cryptocurrencies just have a tendency to be extremely volatile and show a lot of differences in their data. Our architecture is going to be as follows. We set up a Java application for a producer. This is basically just scraping an API and then pushing that information into Confluent. We have two different producers set up. One is going to hit an endpoint that describes all of the conversions between USD and other currencies throughout the world. And then the other is going to grab whatever cryptocurrencies we're interested in. Both of those are going to send the information to two separate topics. We're going to grab information from both of those topics and combine it in our KSQL consumer. That consumer is going to push all of that information to S3. And the S3 bucket is then going to send out an event notification, which is going to go through SQS, get notified by Snowpipe, and then with using that Snowpipe, automatically copy that data into our Snowflake database. And without further ado, we're going to start showing off the demo. I have gone ahead and remoted into my EC2. This is just going to be the host for my Confluent. And then, of course, we're going to have our S3 bucket, our Snowflake, and our Tableau. So the first thing that we set up was our data producers. I'm going to show off one producer here pretty quick. It's about 50 or so lines of Java code. What we leveraged was the Java API that you can use to interact with Kafka and Confluent. And the general idea here is that we just wanted to make sure that we could interact with the server on this machine. So it's pretty out of the box. Once you've got the SDK downloaded, you just set up the properties, which is mostly just the server and the acknowledgements, and then a couple of serializers. Once you have that set up, you can make your own producer. And using this producer, we just push our producer records up to our topic. Our topic here is going to be coin-rate. And the information that we're going to be pointing up is anything that has to do with these tokens in our array. We hit an HTTP endpoint for all of these tokens, get down that information, just USD conversion to that token. And then in our message, we have our base asset, which is just going to be USD, the currency that we're grabbing everything from. That's going to be the key of each of our messages. And then we're going to have the rate and the quote asset, which is just our coin, going up into our topic. And so as a quick show, this is what our messages look like once they're actually sent up to the topic. So as I said, we have two producers. The second one is just sending information up concerning currency conversions. And since those are a little more slow to change, I went ahead and I pre-queried that information, so it should already live in that topic. But the next thing that I wanted to go over is the fact that we are on the consumer side of these topics consuming streams using KSQL. So here in the server, you can actually just type your command KSQL, and it'll bring up an in-terminal interface that you can interact with, exactly like MySQL or any other SQL instance. So for example, if I wanted to show my topics, I can show all of the topics that I've currently got, as well as whether or not they're being consumed by everybody. As we can see, we've got a good amount of consumers for this coins by currency, which is going to be our end stream. But if we look at the streams that we're leveraging, we're going to have three main important ones. We've got currency rates, which is just going to be that conversion between USD and other currencies throughout the world. We have our coin rates in US dollars. And then we have our coins by currency, which this is just going to be a join between the other streams, currency rates and coin rates USD. This was done pretty simply. The syntax for creating coins by currency was as follows: create stream coins by currency from coin rates USD, join currency rates on currency rates key equals coin rates USD key. This isn't the exact syntax, but give or take a couple of changes, this is exactly as difficult as it is to join that information. And once you have that all set up, what you can actually do is similar to any SQL server, I can actually, let's just go ahead and do this. I can select star from my coins by currency. And this is just going to hang and open up a stream. So this is exactly what I've got running here, is just a consumer that's printing out everything that it gets from this stream, coins by currency, which is a combination of the two other streams, to the terminal, as well as dumps that information out here to the S3 bucket. So if we were to run our producer over here, we get three values. That information gets joined with our currency rates. And as we can see here, we've got a whole bunch of messages that came through on both of our consumers. So I'm going to let this run for a little bit. Every 10 seconds, it's just going to pull the prices of these three coins. As you can see, they change pretty drastically in 10 seconds. So that's a lot of the reason that we wanted to do this, was just to not have the same three messages show up over and over and over again. But just looking at the kind of information we're getting out, using that join between those two topics, I have a list of currencies that from USD were described in other currencies. So for example, we've got Ethereum in pretty much every currency in the world, from euros to GBP to USD. If we come up here, just to make sure that we didn't lose any information, there is a USD coin, USD to USD, just to get that straight conversion from USD to the cryptocurrency. So what's happening as this consumer is receiving its data is we are actually putting files out to the S3 bucket. As you can see, we've got a whole bunch that have hit the server just in the last couple of minutes. So since we started it, we've got 1, 2, 3, 4, 5, 6, 7 files that have hit the server. So I'm going to go ahead and let this producer die. But as these files are hitting the server, they will be in this exact same format. And so as they're hitting S3, these are automatically being consumed into Snowflake using what's called a Snowpipe. So to set up a Snowpipe in Snowflake, it's pretty simple. You set up a role in AWS. We have if you'd like to know the specifics on how to set up a Snowpipe, we have some 10-minute videos that'll be available on YouTube. So I'm not going to go too deep into setting up roles and everything. But the idea is you create an integration in Snowflake. You just need a role ARN that has access to this S3 bucket that you're looking at. Once you have that, you can create a stage. And this stage is essentially just going to be a object that you can directly refer to the S3 bucket with. So for example, if I wanted to grab just data directly from my stage, I can actually query it using the syntax select and then row number by $, and the stage name. So here I've just queried a preloaded file I had called hello world.txt. If I wanted to, I could query any of these files directly from Snowflake. But the main feature that we wanted to touch on here was the fact that as our data is coming in, we are automatically ingesting it. So that comes from a feature known as Snowpipe. This is all of the syntax for a Snowpipe. The three things that you need for that are a storage integration. Using that storage integration, you create a stage, which is just a direct reference to the location of the files as far as the S3 bucket goes, and then the file format that you want to consume that from. We are using CSV, but as we can see here, you can also go ahead and parse JSON or put any other kind of information you want in there. Just for simplicity's sake, we stuck with CSV. Once you have that stage created, you can then create your pipe. So here we have create pipe, coin pipe, and I've got auto ingest marked as true. And then this is just created as copy into coin data, which is my currency, coin, and rate. And then one of the unique features of Snowpipe is that you can actually, on ingestion, do manipulations. The manipulation we did here was very basic. I said that I just want to grab all of the data that's coming in from my stage coin data folder. So that's going to be Confluent-Snowflake bucket, and then the coin data folder inside of it. Anything that hits here is going to be automatically consumed by the Snowpipe. And instead of consuming it directly to my table, I set up my table so that it had 3 fields that I could ingest data into, and then a timestamp. As you can see in our data that's coming in, we actually have 5 fields, but there's just certain things that we can kind of take for granted. For example, the fact that this was from USD, we don't really need to grab that information. And this is just going to be a topic number that's used as an internal reference for Confluent. So the only information we were really interested in was rows 3, 4, and 5. However, just to show a basic manipulation, I created the table with those rows out of order. Instead of going coin, currency, rate, I went currency, coin, rate. So essentially just shuffled it. And using these select in Snowflake, similar to how we did up here, I can reorder the columns that I'm selecting from these files as they're automatically being ingested, and I can put them into the order that I want to. Similarly, we could concatenate these files if we wanted to, and you can do basic manipulations. The only thing that's off the table as far as a manipulation inside of your Snowpipe itself is going to be aggregations. You cannot aggregate data as it comes in through a Snowpipe. You'll have to wait until it lands in your table. So if I wanted to just show my pipe, we can kind of go into how this automatic notification system works. It's very simple. You create your pipe, and then you can hop in here and grab your notification channel. It's just going to say it's in US East 1. You grab this and you come into the properties of your bucket, and you can create a notification right on that destination. So now that I've had my pipe made, I can directly query this data, and it's going to come up SQL style because as I consumed it, I parsed out my columns and put them directly into my table. And then the second thing I did, just to kind of show off how you can manipulate this data, is I went ahead and I made a view from the data that automatically landed. So I have got create or replace this USD view. Essentially, all I'm doing is I'm grabbing my coin, my rate, and my timestamp, just all USD for all of the coins where their currency is USD. We could change this to Euro or anything else that we want to, but the main idea stays the same. If we select from here, we've got just a breakdown of the currency of the coins, their rate, as well as a timestamp so that we can create nice graphs and analytics based on that data. And as we can see for today, the 25th, just over the last couple of minutes, we've been real time receiving this data, 9:20:06. And then 10:20. So within seconds, we're receiving these files. These files are dropping here within seconds of getting the initial notification from the producer. And all of this is happening very real time. That's the main focus of the architecture. And the idea behind stuff like this is that, of course, Snowflake is an analytics engine. They even provide their own charts if you wanted to hop over and check out just different analytics here in Snowflake. But what I've done instead is I actually set up a dashboard. And as you can see, it's been consuming data and putting them here on our dashboard so that we can watch them as we consume everything. And again, this is just one of the things that we love about Snowflake is the fact that since it is in the cloud, you can easily connect it to pretty much anything else. But I've got grand total between the two systems, Confluent and Snowflake. For Snowflake, we've got less than 50 lines of SQL here. And if you take out anything that's describing the objects that I've made, you've got 1, 2, 3, 4, 5 total SQL statements to set up an architecture like this. Very painless, very easy to get going and just have an initial success with Snowflake on this level. And then for Confluent, similarly, this was all set up with under 50 lines of code for each producer, and then a similar amount for the consumer. That's the main highlights that we wanted to go over today. I'd like to open this up for the Q&A now.